In this video, we're going to cover a more complicated version of complete the square. Let's recall first off that complete the square is b divided by 2 quantity squared. And again, that's what we're adding and subtracting to this problem. Now this is only true again for the cases where my x squared is a 1. So in this situation, we're going to have to account for that being a 4. The way that we're going to start by doing that is by factoring it out. Now, I can't factor out of these two terms, and this is what I want to do. I want to eliminate the 4 from this x squared and this x term for this to work accurately. In doing so, I need to factor the 4 out. However, this one doesn't have a 4 in it. So what I'm going to do is I'm going to get really creative here, and I'm going to multiply this 2 that's already there by 2 divided by 2. You'll notice here by doing so, again, I didn't really add or subtract anything from this problem. I've put in a multiplication by 1. 2 over 2 is just a multiplication by 1. Again, this is a very smooth transition so that I can make a 4 here and a 4 on top here. So depending on what this number is here, if say this was a 3, I'd have to multiply by a different number that would in order to make it a 4. So in this case, I'm going to have 4x squared minus 4 over 2x. And again, do not simplify that right there because we put that in there ourselves. Okay, so now we have this. I'm going to factor the 4 out of both of these terms. That's going to put it outside these parentheses, providing me with x squared minus 1/2 x. And I'm going to go ahead and write my parenthesis a little bit further out this time, because inside here I want to go ahead and add that box being, again, that b divided by 2 squared. But I need to subtract that box as well. But when I do subtract that box, I'm not just subtracting that box. You'll notice here, if I were to distribute this 4 back into this problem, it would be 4 times that box. So rather than just subtracting the box, I need to subtract 4 and that box. Minus 5 equals to 0. Again, that minus 5 is just carrying down. Now again, I know that this process here is a lot more complicated when there's a number out in front. This number is not pleasant to look at. But if we recall how we did our work before, I'm always going to go ahead and take the number and plug it in for b being the value with x. So if my b is 1/2, that means when I take 1/2 and I attempt to divide it by 2. I don't really like the concept of taking a fraction and dividing it by a fraction, so instead of doing that, I'm going to go ahead and write it this way. It's divided by 2 squared. But any division of a fraction is nothing more than me taking this 1/2, I'm going to write it out in front, that's that 1/2, multiplied by me multiplying by 1/2. So that really is what 1/2 divided by 2 is. It's 1/2 times 1/2 squared. This ends up being 1/4. And again, this number here is the important number. The number right before I square it is what I really want to look at. So 1/4 squared is actually going to be 1 over 16 because I square the 1 and I square the 4 and I get 1 over 16. So this right here is the number that I'm putting in that box. Again, b divided by 2 squared. 1/2. 1/2 divided by 2 is really the same thing as 1/2 times 1/2. And again, if you're not comfortable with that, this thing right here is the same thing as b times 1/2 to the power of 2. So if my b is 1/2, 1/2 gets plugged in there, 1/2 stays right there, and it's all squared. So 1/16 is what's going to go right here, and what's going to go right here. Now that the issue is I need to go ahead and simplify as much of this as possible so that this piece right in here can factor. So let's recall really quick. When we did our factoring, this number right in here, which I'm going to go ahead and put in the half box, the 1/4, that number is important. If we were to attempt to factor x squared minus 2x plus 16, it will perfectly factor into x plus 1/4. Sorry, our b value is a negative 1/2. Let me fix that here, fix that here, fix that here, so that this number here, when I've multiplied 1/2 times a negative 1/2, I get a negative 1/4. So this isn't x plus 1/4, but x minus 1/4. Quantity squared. Now that is again what this stuff here will factor into. Now again, if you don't trust that, by all means, take this thing, write it twice, and FOIL it out. I'm going to carry down the 4. This negative 4 times 1 over 16th is the same thing as a minus 1 over 4. And then I'm going to carry down that minus 5 equals to 0. Again, just to make sure we're comfortable with this, off to the side here, x minus 1/4 times x minus 1/4 is x times x, x squared. X times a negative 1/4 is negative 1/4 x. a negative 1/4 times x is a negative 1/4 x, and a negative 1/4 times a negative 1/4 is a positive 1/16. Again, 4 times 4 on the bottom, 1 times 1 on top. When I combine like terms here, this is x squared, negative 1/4 minus 1/4 of those x's. That means I have minus 2/4, which is really 1/2 x. And you'll notice this is what we had in the parenthesis. Again, this is what we had in the parenthesis back up here. So this is how it factored. And again, it will always factor into that. It'll be x plus or minus that number being whatever it was before we squared it. So this provides us now with 4x minus 1/4 x squared, and then this right here, which I'm going to go ahead and find myself a common denominator between, the common denominator being 4. So I multiply this one by 4 over 4, providing me with 20 over 4. And don't forget that it's a negative. So I have negative 1/4 minus 20/4, which is a negative 21 over 4 equals to 0. So you'll now notice that this right here again is where completing the square has ended. I have completed the square, which provided me with a number out front, something squared, minus or plus a number. In doing so, I can then add the 21/4, multiply by 4, square root with a plus or minus, and then add the 1/4 to get my final result. Again, this is the completing of the process of complete the square. At this point, you are just simply solving the quadratic equation.